contains duplicate to question. First of all, let's see the problem statement. Okay, what the problem statement says is you are given an input of array and an integer. What we have to do is find a distinctive pair of indices in this array such that the value at the array at these two indices is same, but also the distance is less than or equal to k. As you can see in this example, zeroth and third indices are matching, which is having a value of 1, and the distance is 3, which is less than or equal to given k 3. And if you take in the second example, last two elements are matching, which are having a distance of 1, which is obviously satisfying. And if you see this false example, the distance between any two matched elements is minimum of 3, right? Which is obviously greater than 2. That's why they are giving a false. And finally, you can see the constraints here, uh, as you know. Okay, now let's see the first method through which we can solve this question. Okay, uh, we have two conditions here, right? So I first want to eliminate one of these conditions so that I can be peaceful in doing what I'm doing. Let's say our question was just to find two indices such that the values are same at these two indices. Okay, how do you solve that? Uh, One way that I would solve would be to sort the whole array and see adjacent elements so that they are same or not. And okay, if I have some array, then what would I do? Compare the indices to find if their distance is less than or equal to k. So we are going to follow the same approach here also. For this, first we'll declare an array called ARR having size say n. Okay, first for this we need to declare n, right? N would be same as given nums array, which would be nums dot size. Now, what should I do? I should uh, copy these elements back into this ARR array. For each ARR array, what would I do? Since it's a pair of elements, I'm using make pair function. Okay. This first one element would be the num side and the other would be the index. After we do this, what did I say? We'll sort these elements. Okay, we are going to sort these elements, but how do we sort them? These are pair of elements, right? So for this, we are going to pass a comparator function here. Okay, what would be the input for this comparator? It would be the base element of this array. The base element is pair. So it takes these two elements. Now, how we are comparing any pair of elements in this array? That would be by the value of these things. And here I'm sorting them by ascending order. That's why I'm using the less than sign. But we don't want to do this every time, right? We only want to do this whenever these two are not equal. So that's what I have done here. Okay. What do we do when there are two elements that are having the same value? Well, we are going to sort them by their indices in the original array, like this. Okay, now that we have compared those two with using their original arrays, now we know they are sorted. Okay, if we match something while comparing adjacent elements, what do? We find the distance between these two elements. So for finding the distance, I'm using the same ABS function. What this should be less than or equal to k. If this just means that we found a pair of elements for which the value is same and the distance between those two is less than k. Then we return true. What do we mean by getting out of this for loop? It just means that we are not able to find any pair of elements that follows these conditions. So it would be false. Now first let us check with some example test cases. Okay, we are passing the example test cases, so we'll submit and see if we are actually going to work. Okay, we are able to solve this question. Now we will see a second approach. Okay, this is all good and done. What would be the second approach? What first we'll declare all the necessary variables here. Okay, what we want is every time we find an element, we can just directly use some sort of searching algorithm to see if we have found that same element up to now or not. If we have found it, we want to find the most latest element so that the distance should be as minimum as possible. For this, we can use map. This is like the direct use of the map. So we are going to use that. Okay. Every time, what will we do? We are going to find this element. If we found it, we go into this if condition. Okay. Now we found some element which is same as this. We have to see the difference between these indices is same within the realm of k or not. Okay. This minus I should be less than or equal to k. Then what we'll do? We'll return true. Now we have to update this map with the latest index every time, right? This would be the code, the same as the previous logic. If we came out of the for loop, that just means that we haven't found anything. We'll again run through the example test cases and see if we didn't commit any syntax errors. And submit it. Okay, here we go, guys. I've shown you two different methods. Both of them follow this pattern.